Hello, Summer Academy. My name is Ms. Rabinold, and I am a calculus teacher at Troy Prep High School in Troy, New York, and I'm going to be one of the teachers helping you out during this Summer Academy course. I'm really looking forward to it. So let's dive right in. In your Explore activity, you got an opportunity to identify some of the key parent functions that are going to come up again and again throughout this course. So something that we can do with these parent functions is make translations to them. And translations are when we multiply or add coefficients or constants to our parent functions to change them in specific ways. And understanding these translations can help us visualize what a function actually looks like were we to graph it. Or it can help us graph these parent functions without having a calculator, which is a really helpful skill. So I'll share my screen and we're going to take some notes on translations together. Awesome. So we have 4 different types of transformations of functions that can happen. So first is notated by this constant a, which is a coefficient outside the parentheses. And this particular coefficient outside of the parentheses is going to represent a vertical stretch. So this coefficient a could take our parent function and make it taller or make it shorter. And also, if this value a happens to be negative, then that would correspond to the function being reflected over the x-axis. Similarly, we have this constant b, which is a coefficient inside the parentheses. Similarly to b, this represents a stretch, but instead of a vertical stretch, b represents a horizontal stretch. So by increasing b, we can make our parent function wider, or by decreasing it, we can make it skinnier. And then similarly again to a, if this value happens to be negative, this would represent the function being reflected over the y-axis. So a has to deal with vertical stretches and vertical reflections, and b has to deal with horizontal stretches and horizontal reflections. Let's take a look at c. C represents this constant that is being added or subtracted. And c is inside or within the parentheses. It's inside the parentheses. Now c, this constant, is going to represent a horizontal translation. If we have a plus c, a positive c, this translates to our function moving to the left. Plus c moves our function to the left, whereas a minus c will translate our function or move our function to the right. Awesome. And then lastly, we have d. Now d is again a constant, but it is being added or subtracted outside the parentheses. And this constant D will represent not a horizontal translation like C, but D is going to represent a vertical translation. If we have a positive D plus D, this will translate our function up. And a minus D or a negative D will translate our function down. So something that you might notice here is that if our coefficient or our constant is outside the parentheses, that means it's dealing with something vertical, a vertical stretch or a vertical translation. If our coefficient or our constant is inside of the parentheses, that has to deal with something horizontal. It could be a horizontal stretch or a horizontal translation. So let's keep that in mind as we look at example number 1. Awesome. So example 1 reads, name the parent function and identify all the transformations of this function. And our function is y equals -3 times the quantity x minus 4 squared plus 6. So first we're going to identify our parent function. Which is going to be one of the types of functions that we identified in the Explore activity. I see this squared, this exponent of 2 on that parenthesis, the quantity in the parentheses. So that indicates to me that our parent function is a quadratic. This is also sometimes called a polynomial parent function. Polynomial is just a more general name. A quadratic means we have specifically an exponent of 2. A polynomial could be any exponent, any constant exponent. So that's our parent function. Now let's identify all of the transformations that are happening. Let's analyze these coefficients and constants that are being added, subtracted, or multiplied. So first thing I notice is that I've got a -3, a coefficient of -3, and that is outside of the parentheses, right? The squared does not apply to this -3. It is outside. So if I have a coefficient outside of the parentheses, that's going to correspond to a vertical stretch. So first of all, this function has a vertical stretch of a factor of 3. But also, this is a -3, and that negative indicates something else. That negative indicates that we actually have a reflection over the x-axis. Okay, let's keep going. Inside these parentheses, we have an x minus 4. Well, we know if we have a constant being added or subtracted inside those parentheses, that corresponds to a horizontal translation. And I see that this is a -4, and minus our C value indicates that it's a horizontal translation to the right. So ultimately, this is a horizontal translation 4 units to the right. If it were a x plus 4, it would be 4 units left. Awesome. We have one more translation or transformation, sorry, which is this plus 6, and that plus 6 is outside of the parentheses. This is our D value. If we have a constant being added or subtracted outside of the parentheses, that is a vertical translation. And this is a plus 6, a positive 6. So that indicates it is a vertical translation in the upward direction. If it were a minus 6, it would be moving downwards. So this is a vertical translation of 6 units up. And that is all of the transformations in this function. You guys are going to go to practice set A now and try out some questions where you are going to get the opportunity to identify the transformations of some of our parent functions. Give it a shot. Awesome. So now that you guys have an understanding of transformations of functions, we're going to talk a little bit more about vocabulary and then how to actually solve functions and how to evaluate them. So there are 3 key parts of a function. First is the name of the function. In this case, it's f. This is the name of the function. Right, so if we were going to read this line of math out loud, we would pronounce this as f of x, with f being the name of the function. The second key piece is this x, which corresponds to our input. X is the input for this function f. This is also sometimes called the domain. And lastly, we have the output of the function, which is this 3x plus 1. This represents the output, also known as the range. Now, having a really good understanding of our parent functions and translations can help us figure out how to graph those functions or what the graphs of those functions will look like. So when we are evaluating functions, we can match up what we find algebraically with what we find graphically. So let's take a look at this in example 2. We're going to evaluate the function f of x equals negative x squared minus 6x plus 12 for x equals 4. So you can see already there is a graph of this function f of x. And so one way that we could evaluate this function is by doing it graphically. We can go to the input x equals 4. So I go to the input x equals 4 and then see what the output would be. And in this case, it looks to be a little bit more than negative 30. Okay, so that's one way. Maybe that's negative 28. We can also do this algebraically by plugging our input into the function. So we have the function f of x equals negative x squared minus 6x plus 12. And we want to evaluate this function at the input x equals 4. So what I'm going to do is replace every x that I see with the input that we want, in this case 4. So everywhere I see an x, I'm just going to write a 4. So this will be negative 4 squared minus 6 times 4 plus 12. And then I can just use my order of operations and simplify. So f of 4 must be equal to negative 4 squared is 16. Negative 6 times 4 is negative 24 plus 12. Okay. I know that negative 16 minus 24 is negative 40 plus 12. Negative 40 plus 12 is going to give us negative 28. Oh, fantastic. That is exactly what we saw on the graph. If we went to the input, x equals 4, and then saw the value of the graph at x equals 4, we got negative 28. So this aligns perfectly with what we found algebraically. Awesome. Now you guys are going to head to practice set B and practice evaluating functions both using graphs and also using our algebra skills. Give it a try. You got this.